Hello guys. So in the series of integration by parts method, multiplication rule, substitution, through substitution we make the functions as a standard functions. We integrate the trigonometric functions, inverse functions, log functions. We are doing some such important questions on the basis of inverse functions. Working rule in these questions is: first, we substitute. After substitution, we make the function as a standard function. Then we use by parts using multiplication method and integrate that in terms of theta or t. And finally, we substitute once again and regain the function in terms of x. Right? So this is the scenario. We will use this. So the important questions, just like question number 1, it is integrate. This is the most important question. Sine inverse minus sine inverse root x minus cos inverse root x, and it is divided by sine inverse root x plus cos inverse root x. Now, as we know, in the formula of inverse trigonometric, sine inverse x plus cos inverse x is pi by 2. So we use this theorem in denominator, so it becomes pi by 2, and we can convert this and getting the value of cos inverse x, that will be pi by 2 minus sine inverse x. So we apply this at this position. We have sine inverse root x minus, we substitute the value of cos inverse in terms of sine inverse, that will be pi by 2 minus sine inverse root x. So it becomes 2 over pi, this is comes out, and this is sine inverse root x so it is 2 over pi and twice sine inverse root x minus pi by 2. Now we multiply this and separate this, we get 4 over pi sine inverse root x, and this is 2 over pi and pi by 2 dx. So right now we have the simplified form of this expression is sine inverse root x, and there is x only. So our focus on this part, we will integrate this, so we can take it separately and finally we put the value of this integration at this position. Right now we have 4 over pi sine inverse root x, and this is minus x plus c. So we want to integrate this, we take it separately. So integration of sine inverse root x dx, we substitute, let root x equals to sine theta, so x is sine square theta, and differentiation of this is 1 over 2 root x dx cos theta and d theta. So dx equals to is 2 root x cos theta d theta, and when we substitute the value of root x as sin theta, so we get it is 2 sin theta cos theta d theta. Now you can say it is sin 2 theta also, so dx is sin 2 theta. Right now we substitute these values. Sin inverse sin theta, we substitute the value of root x as sin theta, and the value of dx is sin 2 theta d theta, and this becomes theta only, and it is sin 2 theta d theta. So right now we use Eilert. According to Eilert, right now we have two functions, algebraic and trigo. According to this, algebraic function has higher priority, so it is first part and it is second part. Now we use by parts method. According to by parts multiplication method, theta as it is, integration of sin 2 theta, that becomes minus differentiation of theta and integration sin 2 theta d theta, and overall once again integration. So it is theta, and this is minus cos 2 theta by 2, and there is it is 1, and this is minus cos 2 theta d theta, and this one will be converted into half theta cos 2 theta, and this minus become positive, and this is 1 by 2 cos 2 theta, and we get a final result in terms of theta. Right now we have integration of this, and this is sin 2 theta divided by 2 plus c. So this is the overall integration, but answer should be in terms of x, so we will use substitution method once again. Right now we have result half theta cos 2 theta plus half, which is 1 by 4 sin 2 theta, and we consider root x as sin theta, so theta is sin inverse root x, and according to this, if we form a triangle and we put 1, sin theta is perpendicular to hypotenuse, so it is root x over 1, so this becomes 1 minus x. So we can collect the value of cos theta also, that is under root 1 minus x. So right now it is half theta, we can put it in terms of sine, that is 2 sin square x, 1 minus 2 sin square theta. This is the value of cos 2 theta. And sin 2 theta is 2 sin theta cos theta. Now this becomes 2 sin theta cos theta. So it will be cancelled out. You get 2. It is half theta minus cancel out. We have sin square theta, and there is 1 by 2 sin theta, and the value of cos theta is 1 minus sin square theta. So we can substitute these values. theta is sine inverse root x. So half sine inverse root x. And the value of sine square theta, this will be x, means x is sine square theta, and plus half sine theta is root x, and 1 minus sine square theta is 1 minus x, plus c. So this is the answer, right? So we put the integration, final integration of the sine inverse root x at this place, and we get the final result. So previously we have expression so this is the integration of sine inverse root x. So we put this value at this place, so it will be 4 over pi, and this entire value sine inverse root x by 2 minus x and half under root of x into 1 minus x. So it is minus x plus c. So this is the answer. Now the next question is integrate sine inverse of under root x plus a plus x dx. So again, this is not a standard inverse function. So according to working rule, first we will use substitution, then by parts, then once again substitution. So right now the first step, we substitute this. So we consider, let x equals to a tan square theta. Right now we differentiate this, so it is a 2 tan theta, this is x square theta d theta. Right now we substitute this value, sine inverse x is a tan square theta, this is a plus a tan square theta, and the value of dx is a into 2 tan theta x square theta d theta. So it becomes sine inverse a tan square theta, and when you take a as common, so we get 1 plus tan square theta, and 1 plus tan square theta is x square theta, and this is 2a tan theta sec square theta d theta. So right now this a will be cancelled out, and tan square theta and sec square theta, so it is sine square over cos square, this is 1 over cos square. So when we put the value, it is sine square theta over cos square theta, and this is 1 over cos square theta. So cos square theta will be cancelled out, and this is under root sine square theta. Now this is 2a, and this is sine theta, sine inverse sine theta, and this is tan theta sec square theta d theta. This becomes theta only, so this is algebraic function, this is trigonometric function. So it is first and this one is second. Right now, by substitution, we convert this modified function into a standard function. Now we can use by parts. So if we integrate second part, this is first and this is second part. So the integration of tan theta sec square theta, if we consider, let tan theta as u. So this is sec square theta, d theta is du. So tan theta is u and the value of this is du. So it is u square by 2, means tan square theta by 2. So this is the integration of tan theta sec square theta. Now we apply by parts method. It is 2a theta as it is. We integrate the second part, which is actually equals to this, minus we differentiate first part and integrate second part, and once again integration. So we have 2a theta and the integration of this part is tan square theta by 2. So we can put it directly, minus it is 1 and this is tan square theta by 2 d theta. So it is 2a theta tan square theta minus 1 by 2. We can place tan square theta as sec square theta minus 1. So it becomes half theta tan square theta, and this is half integration of sec square theta is tan theta and it is theta. Now after this we substitute values of our assumption in terms of x. We convert it into original terms x. So it is multiplied this and we get 2 से 2 cancel and it is a theta tan square theta. This is 2 and 2 will be cancelled, a tan theta plus a theta. We considered x as a tan square theta. So tan square theta will be x by a, and theta, this is under root and it is tan inverse of under root x over a. So we can place this. It is tan inverse root x over a. This is the value of theta, and the value of a tan square theta is x. So we can place x minus a tan theta is under root x over a, and this theta is tan inverse root x over a plus c. So this is the answer.